right. Thank you so much for being here. I'm Theresa Williamson. I'm a neurosurgeon at Mass General and one of the co-directors of the Neurotech Justice Accelerator at MGB. You can see our life-size faces over there with my other co-director, Francis Shen and Gabriel Lázaro-Muñoz. First and foremost, I want to thank Florette and Jennifer from our NJAM team who have done just an unbelievable job setting this up on really short notice. They make this entire thing possible. I think it's very safe to say that they took sort of what Gabe and Francis and I were bootstrapping and made it into a real professional event and program. So we're just deeply grateful for that. And then also to thank our Dana team, Caroline Monta, who's here, Ishan Dasgupta, who's here, Kara Ramos, who's online, and all the folks at Dana, because your support really makes this possible. And then I want to tell you, and then also, of course, our Mass General Brigham neurosurgery team and chair, Dr. Kyoka, who you'll hear from shortly. I want to tell you a little bit about our Neurotech Justice Accelerator at MGB. I think it's something we're deeply, deeply proud of. When we, Francis, Gabe, and I kind of met a few years ago fortuitously at the Center for Bioethics, and we were all sort of these misfits in neuroscience. And we found different ways to sort of make ourselves fit in. You know, Francis was like, I'm just going to create neuro law and make a job for myself. Gabe was like, I'm just going to get a bunch of different degrees and then see where I can put all these things together and become this research powerhouse. And then I was this neurosurgeon who I did my training at Duke. And I remember saying, you know, I had a very typical neurosurgery resume with cell biology and cerebellar growth factors and all the things you're supposed to do. And I went to my chair, John Sampson, at the time, and I was like, I'm really way more touched by what happens to patients and the decisions they make at the bedside and whether or not they have, you know, decide on technologies. And I think I'm way better at that. And so I want to do this thing where I link the neurosurgery to the society and study decision making. And he was like, great, but you're not an English major. You weren't a philosophy major. Like, you basically have no skills to do this job, which was absolutely accurate. And so, you know, I had to go and kind of forage around the campus to find people, almost none in neuroscience, to give those skills and to figure out the skills in ethics and decision making and those types of research, but there wasn't a particular home for that for me. And so when I came here and convinced Bob Carter that this could be a job, you know, started really this career in neurosurgery and neuroethics that I'm so grateful for, and brought me to Francis and Gabe. And I think, you know, from there, it's really taken off because we share a passion for the idea that this neuroscience frontier is going to impact society in ways that we could have never expected. And we share a dedication to bringing trainees and collaborators into that space and giving them opportunities that we didn't necessarily have in a new sort of field of neuroscience and society. And I think we've already seen that this is working. It's really wild because I thought, you know, I was one of the few people brought to neuroscience from seeing family members be system involved with mental health challenges. And then I heard Craig's story last week. And then I heard, you know, other folks' stories and people in this room that have written books on these topics. And I thought, oh my gosh, what if there was some type of center that could bring people like that together and then give them access to researchers so that actually the experiences we've lived could impact the patients that we care so deeply about, and how would the world be different? And I think we're standing in the beginnings of that. And I'm really, really proud of that. And then I think the other piece is we need the knowledge. We need to create the knowledge to lead the field. And we have such a rich ecosystem here at MGB, at Harvard, to do that. So we're so grateful for all our collaborators and our students who are here to really experience and grow that mission. We had some of our students in the OR this week. It was awesome watching them like sort of walk around the blue tables and not touch anything and get to see things. Reminded me of my first exposure to neurosurgery, where I forgot to wear my hat and I got like screamed at by the surgeon. They're like, get out of here. And then I thought like, okay, I'm walking out and I'm never going back into neurosurgery. Like, that's it. And it actually turns out that that surgeon and I sit on the Congress of Neurological Surgery board together now. We just found this out like a couple months ago. I was like, you're the guy that yelled at me for not wearing the hat. And so I think, the reality is I look forward to serving on the board with you guys someday, and to all the beautiful things you're going to do for this field, because it really just is an amazing group of people, and you have such great support here. So with that, I'll introduce our Dana team. Thank you so much to Caroline Montajo, the CEO of the Dana Foundation, for being here.
Here are stairs. Hello, good morning, everyone. It's so wonderful to see everyone here. Greetings as well to those who are online. It's wonderful to be here. And I want to thank Theresa, Gabe, and Francis for having us here today. It's such an honor and very exciting to see this work sort of coming to life. And also I want to thank Marcela Del Carmen as well as Nino Kioka for their championing of the Dana Center and really helping to highlight and uplift these very talented and visionary leaders that we have here. So as Theresa mentioned, I am Caroline Montajo. I'm president and CEO of the Dana Foundation, and I'm joined here by my wonderful and esteemed colleague, Ishan Dasgupta, who is the director of the Dana Next Gen program. And we'll just speak very briefly. I'll share a little bit about the Dana Foundation, as well as the inspiration for starting the Dana Center initiative. And then Ishan is going to share about what drew us to MGB as a partner for this initiative. So I also just want to acknowledge Kara Ramos, our Vice President of Neuroscience and Society, is in the ether, as well as is Farron McEntee, who was our Dana Fellow, who worked so closely with us to establish this. Craig, great to see you. Oh my gosh, wonderful to see you all here. All right, so a little bit about the Dana Foundation. We are a privately endowed philanthropic organization based in New York City. We are celebrating our 75th anniversary as a foundation this year, and we were honored to have many of the NJAM members join us in New York City for our celebration last week. Craig McFarland, one of the fellows here in NJAM, even gave some remarks for our board, all of our staff, and all of the other Dana Center sites, which was really exciting. And so, as we think about our history, the foundation has supported science and higher education for these past 75 years. Some of our investments in the early days were the Dana-Farber Cancer Institute. We also supported many independent colleges across the country. And then building on that mission area, about 4.5 years ago, we refined our focus to really support the intersection of neuroscience and society. And so what brought us there was that we recognized that neuroscience was advancing in really incredible and exciting ways. So many neuroscience discoveries and neurotechnology developments held this potential to transform our lives in everything from healthcare and well-being all the way through to education and justice. And then the other thing we recognized in our conversations with many in the science community is that some of these advances were progressing so quickly, sometimes ahead of the public dialogue on potential uses and misuses, risks and benefits of these developments. And so that's what led us to get into this work to help shape the future of neuroscience and neurotechnology with people from many fields, as well as with the communities that the science is intended to serve. And so our vision is brain science for a better future. Our mission at Dana is to advance neuroscience that benefits society and reflects the aspirations of all people. So very much a bidirectional relationship between science and society. And we fulfill this mission by investing in and building the field through education, next generation training, and bidirectional public engagement on neuroscience and society topics. This can include areas like brain-computer interfaces, neural organoids, and assembloids research. And so when we set forth to implement this mission, we recognized that the Dana Center initiative would really be at the heart of it. And so what it is a nearly $20 million partnership between the foundation and research institutions, scientists, scholars from other fields, and the communities they serve to be able to have the space to co-create the future of neuroscience. And so these Dana Center initiative sites are asking really big questions like, where do we want neuroscience to take us? And how far is too far? And where can it most benefit our lives? And so after receiving more than 40 competitive proposals for Dana centers, we were absolutely delighted to be able to partner with Loyola University Chicago, Mass General Brigham, as well as UCLA partnered with Charles Drew University. And I also just want to say, I believe this is such a critical time, a critical and challenging time for science and higher education. And I believe that the foundation's commitment to these areas, in my mind, holds such a renewed meaning and a renewed purpose and responsibility in today's world. So I'm so grateful to be able to work alongside and support incredible visionary leaders like Theresa, Francis, and Gabe, and all of the trainees who are in the room today. You are the future of neuroscience, and I really look forward to getting to know you over the course of the day. I also recognize that this center here, NJAM, involves a lot of very deep collaborations, and that includes the University of Minnesota, where Francis is based. That includes the Petrie Flom Center in the School of Law. This also includes the Center for Law, Brain, and Behavior, Harvard Brain Initiative, also the Museum of Science, as well as the Suffolk County District Attorney's Office, and More Than Words. So those are just a few of the collaborators involved in this very multi-institution center. So I just want to thank you all for the incredible work you do. I really think that it's only by working together that we can really make change in the world. And so I thank you for that spirit of innovation and collaboration. And so with that, I'm going to invite my colleague Ishan Dasgupta to come and share about what drew us to this partnership. In particular, we were just reflecting last night that about 4 years ago, we turned to each other and we said, Ishan was my very first hire at the Dana Foundation. And we turned to each other at that point, thinking about what we could do, what we could support. He said, do you think we could really build this? Will people actually want to do this kind of work? And when I look around the room today, and when I think about who's online, I feel like, this is really the future of neuroscience for the benefit of society. So thank you. I'll invite Ishan to come up.
Good morning, everyone. My name is Ishan Dasgupta, and I lead the Dana NextGen program, which is focused on supporting trainees at the intersection of neuroscience and society. I just want to echo Caroline's remarks and thank the entire NJAM team, as well as the leadership at MGB. The goal of the Dana NextGen program is to strengthen neuroscience's positive role in the world by preparing the next generation of scholars to think reflexively and responsibly apply neuroscience knowledge to benefit society. And we do that through 3 different ways. First, through training opportunities, second, through workforce development, and thirdly, through collaboration across disciplines. As Caroline mentioned, when we embarked on this Dana Centers process, one of the primary goals was to create a space for the future trainees to grow, flourish into experts that'll help us navigate some of these immense challenges in both the ethical, legal, and societal issues raised by the advancement of neuroscience and neurotechnology. However, as many of the people who have worked in fields such as neuroethics and neurolaw know, it's extremely difficult to build an interdisciplinary curriculum or career. Often, if you're studying to be a scientist, you might not have a chance to explore courses in history, philosophy, or sociology, as Theresa just mentioned. If you're on the other side, if you're a budding social scientist, you may not have access to robust training in the natural sciences. And even those of us who were fortunate enough to have interdisciplinary careers only did so because we happened to be at the right institution at the right time and had mentors who really believed in us. So one of the main goals of the Dana Centers was to reimagine how we train students. We asked ourselves, what if we could create a home where students interested in bridging disciplines and boundaries could come to take the relevant courses to get hands-on experiential learning and mentorship from faculty across disciplines. And in NJAM, we believe we've found that home. Starting with a dream team of co-directors that bridge expertise in things like medicine, surgery, neuroscience, law, ethics, and even more, we couldn't have imagined a better team of co-directors than Theresa, Gabe, and Francis. And not only do they exemplify this level of interdisciplinarity, but they also have really strong track records as caring and thoughtful mentors. But talented faculty isn't enough by itself to sort of create this sort of training home. The institutional context is just as important, and we can't think of a better home than at MGB. I mean, where else can a lawyer interested in harnessing neuroscience to further criminal justice go to receive the relevant training? As Francis has recently reminded us, I don't think there's another place in the country that allows that to happen. Where can a budding philosopher of science get the opportunity to be embedded in a department of neurosurgery, getting the chance to witness cutting edge research in medicine and practice, gaining insights that can not only inform ethical inquiry, but help us understand how brains work? I can't think of many other places. Lastly, where can a medical student interested in neurosurgery learn how to better reach their community and think about issues related to equity and access? I think MGAM is the place where you can do that kind of work. So I'd like to say, I again want to thank Theresa, Gabe, and Francis for being able to create this, very unique and special place. And we really can't wait to see what NJAM trainees do in the future. And especially to all you trainees here today, and especially the new cohort of NJAM Summer Fellows, I want to say that the Dana Foundation is here to support you in any way we can. And if I don't get a chance to talk to you today, please do reach out to me, because we want to hear about what you're working on and what you're excited for the future. So thanks, everyone.
Thank you so much. As we transition to our next speaker, Dr. Kioka, can our trainees just raise their hands? Perfect. There we go. So lots of people, lots of connections to talk to today. And I'm really grateful that Dr. Kioka was able to get out of the OR for a moment. So this is real, neurosurgery and neuroscience live and coming to reality as we want it to. And so he's going to make some remarks. Thanks, Dr. Kioka.
Thank you very much. So first of all, I wanted to thank the Dana Foundation, Carol and Ishan, for the great support you're providing Mass General Brigham. I am Nino Kioka. I'm the chair of MGB Neurosurgery. Second, again, I wanted to also forward my congratulations to Francis, Gabe, and Theresa for really setting up this amazing program, as well as this Neurotech Justice Accelerator at Mass General Brigham. Third, I wish I could be there with you. At Mass General Brigham, we pride ourselves with the idea that patients come first. And unfortunately, I could not get out of this operation I had to do to be there. My plan was to be there in person. And the reason I wanted to be there in person was to learn more about this. We are confronted now in neuro every day with the ability and increasing technology where we can actually modify nervous tissue, we can modify the brain, we can modify the spinal cord. And some of these modifications with emerging technologies, stimulation, deep brain stimulation, brain-computer interfaces are really done for purposes that we think are great. Restore the ability to walk to a paralyzed person, restore the ability to move an arm for an ALS, a person suffering from Lou Gehrig's disease. But clearly, there are many potential applications that one can think of. And if you read just the literature on review articles, people talk about all types of diseases that we potentially could confront. But like everything in humankind with human behavior, there's also the possibility for things that we don't think may need repair, but potentially could be used for ameliorating things like intelligence or other parts of the brain that have been silent. And, so I think that there is all sorts of ethical, legal, regulatory, and societal issues that we need to start confronting. And I think that this effort that you all are leading is going to be key in helping us figure this out. So thank you for all you're doing. I wish I could be there in person. And thank you for setting up this great program. Appreciate it.
Thanks so much, Dr. Kioka, for being here. Good luck with your case, and thank you for taking such great care of our patients.
Thank you.
All right, that's a great transition to the emerging technologies and evolving patient realities. I'll just ask our panelists to come on up. Yeah, come on up, Yelena. And Gabe and I will be, we'll be moderating this session. So our first panelist who will be joining us is Yelena, and then we'll have Dr. Joe Fins. Dr. Yelena Bodine, come on up, Dr. Sriya Srivastavanan, Dr. Nathan Rowland. Yep, and you have a picture on your seat where you're Dr. Lee Hochberg. And Dr. Ziv Williams is joining us virtually as, oh, there he is. Perfect.
How are you doing?
Hey, Dr. Williams. Funny story, Dr. Williams and I have very close names, obviously, and we had the same admin when I first started here. And so my first case, I got called to an emergency case, and it wasn't mine, it was Dr. Williams. And I was like panicking. It was like my first day. Well, thank you guys so much for being here. I don't want to waste any time because this is just such an incredible panel. We couldn't narrow down enough the talent and the amazing people in neurotech. And so this panel is really just about hearing what's out there. I learned a lot just talking to the panelists about what's out there. And we're going to start with Dr. Bodine, who's going to tell us, she's an assistant professor at Vanderbilt University Medical Center, but those of us that know her well know that she's near and dear to us as she was previously here at Harvard and at Spalding. So we've asked everyone to use just one slide in just a few minutes to tell us their most exciting sort of new findings. And so let me see if I can get to your slide. There we go. Come on up. Forward button. This guy here. Yeah, okay.
Hi, thank you so much for having me. It's wonderful to be back. I've been away for just under a year and can't say how much I miss everybody here. That's certainly the thing that I miss the most about Boston, not the traffic. So I wanted to challenge us to think about something that will probably frame how we think about a lot of the technologies that we're going to hear about today. So we surveyed over 250 people with severe traumatic brain injury and 250 caregivers. We presented them with a clinical scenario of a patient who had a severe traumatic brain injury and had a very uncertain outcome. They were on a ventilator. When we think about technologies in this space, we sometimes don't think about something like ventilators. They've been around since the 1960s, maybe even earlier, but they pose an ethical challenge for us as well. So we asked these 500 folks what they think would be the minimally acceptable outcome after a severe traumatic brain injury, the final outcome for a person, what would be acceptable to them? And we presented them with the outcomes that you see here on the screen. Now, in your head, just read through them kind of carefully and put a circle in your mind around the outcome that you think would be minimally acceptable for yourself or for most people with a severe traumatic brain injury or their caregivers. So here's what we found. The overwhelming majority of people who we surveyed selected an outcome that was far more reflective of far more impairment and disability than what we normally call a favorable outcome. We normally consider a favorable outcome to be independence, return to work, full recovery. But in our survey, the majority selected an unfavorable outcome to be one of the outcomes that was minimally acceptable to them. And this is work that we've done with Gabe and with others that we're hoping to be able to publish very soon. So now keep that in the back of your mind. Why might this be? So if anyone's heard of something called the disability paradox, we know that there is actually a dissociation between level of function and life satisfaction. And we'll probably see that in some of the other talks that we're going to hear about today. So in the world of traumatic brain injury, the outcome measure that we use the most is called the Glasgow Outcome Scale Extended. It goes from a score of 3, or really 2, but we're going to talk about 3 through 8 here. And so we took a look at people with different levels of impairment on this measure, the GOSI. You see the top 2 rows there indicate unfavorable outcome. The bottom rows indicate favorable outcome. And we looked at satisfaction with life across different levels of disability. And as others, we found a dissociation in 2 directions. So first, in that blue box, you see that a significant proportion, about 40% of people who have a severe impairment, rate their satisfaction of life and the satisfaction with life scale to be average or above average. But similarly, and this is something that we've talked about quite a bit, there's a substantial proportion of people who have a favorable outcome on all of our typical TBI outcome measures, and they report a lower level of life satisfaction than the average person. So this is considered in many ways to be a demonstration of the disability paradox, a dissociation between how people are living their life in terms of their day-to-day function and how they feel in terms of how satisfied they are with their life, something that's going to be very relevant in the neurotechnologies as they evolve. Now, why is this important? So this is the last data point that I'm going to share with you today. When patients are in the ICU and they are recovering from a severe traumatic brain injury, many families are faced with a choice. Should we prolong life support, like the ventilator, or if the patient is going to have a poor neurological outcome, should we consider discontinuing life support, taking out the breathing tube, turning off the ventilator so that they can peacefully die in the ICU and not have to suffer the many years that they might have to suffer in a state that would be unacceptable to them? Now, of course, I just showed you that that state might actually give them great life satisfaction, but that is the clinical reality. And so we asked the question, for patients who died after life support was withdrawn, what would have happened if we did not withdraw life support? Could they have recovered? And we did some statistical modeling to answer this question. So we have three levels of data here. The tier 3, these are the patients who are the most severely injured and the oldest. Tier 1, these are the patients who are the youngest and the least severely injured. And again, we're using the GOSI as our outcome measure, but here's what I want to share with you. What we found in our statistical analysis, and Dr. Williams is an integral part of this study, we found that our projections showed that some patients who died after withdrawal of life support, they were probably going to die even if life support were prolonged. And that's what you see in these gray bars here. But some patients, they probably would have made a full recovery had life support not been withdrawn. And among the survivors, almost 40% would have had what we typically consider to be a favorable outcome. So as we go forward with the next panelists, I just want us to really question the assumptions that we bring to the table when we think about neurotechnology, when we think about what it means to have a meaningful life. And I want us to challenge the assertions that are all around us in the medical field, in ethics, in neuroscience, so that we can be better stewards of the technologies that we're going to have in the future.
There's a lot of food for thought there. It's a great transition to Dr. Joseph Binns, who's the William Davis Professor of Medical Ethics at Weill Cornell University, and then a visiting professor of law at Yale Law School. Thanks, Dr. Binns.
Thank you, Theresa. And it's great to be here. And thank you to Dana for all you guys do. So I have one slide, which I hope you can read. And I want to basically summarize 25 years of my life in 5 minutes. Okay,
Perfect.
So fasten your seatbelts. So what my bottom line is, and I think it's part of the ethos of the program here, is that neuroscience and neuroethics are better together. And you can't do one without the other. And I want to just give you a couple of highlights along this trajectory of when that was important. So the first thing I want to do is talk about our work that I've done with Nico Schiff and others, deep brain stimulation in patients who have severe brain injury. And the very first slide is a cartoon from Nature Neuroscience a few years ago, where we talk about the meso circuit. And this is the sort of the roadmap of the brain where you can intervene to basically take somebody who has a disorder of consciousness or severe brain injury and make their brain work better by integrating cortical function from that central feature in there. Let's see, how does this work? This is the thalamus. The thalamus is to the brain what Hartfield's airport is to Delta Airlines. It's the hub. You can't get there from here without going through the thalamus. Right, Lee? Right. Okay. So there are lots of ways. He's a real neurologist. There are lots of ways to intervene. And one of the things that we did is we actually stimulated the thalamus with deep brain stimulation. And what that does is it improves the connectivity, from the brain stem, which is sort of the energy source for the brain, and integrates cortical function. And this is a paper that we published in Nature in 2007. It's not presenting well here, but this was in the minimally conscious state, a patient who appeared vegetative, but every once in a while they would demonstrate some behavior, eye movement that suggested that they were there. But they had sort of an intact highway system, this neural network, but it was underactivated. So with deep brain stimulation, we activated, and this is a person with deep brain stimulation. This was in Nature, who could say 6 or 7 word sentences, could say the first 16 words of the Pledge of Allegiance, tell his mother he loved her, go to Old Navy and say, this is the kind of clothing I want. Before that, he could not speak. And so the ethics that played into that, I'm sorry, going back to this, the ethics that played into that, was that we had to start somewhere, and we ethically started in a patient where we couldn't do a whole lot of incremental damage. and we demonstrated proof of principle. More recently, in a paper that we published in Nature Medicine in 2023, we did deep brain stimulation in patients who could provide their own consent. They weren't minimally conscious. They were sort of the walking wounded, like our veterans after the wars in Iraq and Afghanistan, or people that appear normal but they can't hold the job, and they're limbic, and they have disordered relationships with their family members. All the people in this study, we enrolled 6 people, were well enough to provide their own autonomous consent as adjudicated by a consultation liaison psychiatrist. So what we did is we published that paper in Nature Medicine in 2023, and there were 5 people completed the study. All 5 of them had an improvement of the trails making part B, a 10% improvement, which is evidence of cortical functioning, executive function, and the like. But nobody really cares about trail making part B, right? Does anybody really know what that is in this room? No. So what we did, you do, okay, because you're a smart guy. Okay, but what we did was in tandem with that NIH grant, and by the way, this was funded by the NIH, so we have to hope that all continues in the future. We did a parallel study of doing narrative interviews, also funded by the NIH, of patients before and after the study and their family members, okay? And we have 2 long papers that were published in Cambridge Quarterly, each one thick descriptions, about 18,000 words each, describing the lived experience of these people. I'll talk about science and society. This is a science in a family, individual families. And I just want to highlight one finding, which kind of blew my mind, and that is, it's about personal identity. There's a lot of talk in neuroethics that if you get, a stimulator in your brain or BCI, we're going to rob you of your personal identity. We're going to hack your brain. You're going to lose your cognitive liberty. Okay, that's the myth. That's the parable that philosophers share with us because it makes for good reading. But if you actually ask the people who were involved in these experiences and you actually interview them with narratives, it turns out that they have an identity. The brain injury takes their identity away. Not the technology. And it was restored with the deep brain stimulation. People say, when I had my injury, I was kind of like a teenager, but now I'm back to my age. Family members say they've gotten their sense of humor back. Their interests have come back. They've returned to who they are before they had the injury. So I think it's important because there's empiricism to this kind of ethics. And then finally, a project that Gabe and I are working on now with NIH funding, we're talking about post-trial obligation to people. You get your identity back, but there's no policy to guarantee that you have continued access to the stimulators, to the battery replacements and the like. So Gabe and I are doing a Delphi analysis following on this kind of work, not just in TBI, but in psychiatric illness and the like, to say, okay, what kind of policy should we have to help restore policy, maintaining the identity so people don't lose it after they've been helped by the neuroscience. So, we have this paradox, and I think Carolyn was talking about it. We have the fruits of neuroscience at a time it's as robust as it's ever been, but we have it potentially all at risk if we don't sustain it and fund it. And so we're looking at ways to maintain people's identity, because in a way, if you think about disability law, which is one of the things I've been very interested in, to maintain your identity is the ultimate accommodation, the ultimate disability accommodation. And I don't think there's anything more compelling than to maintain these people's sense of self after it's been restored. And how tragic it would be if you have that glimmer of who you once were to have it taken away from you because we don't have good policy or we don't have funding. So I'm really grateful to be part of this wonderful team. I'll end there. Thank you, Theresa. Okay.
That was masterfully accomplished in one slide. You got a little sneak peek for a second of Dr. Lee Hochberg, who will be our next speaker. Who's let me go back. Oh no, no spoiler alerts. Who's the director of the MGH Center for Neurotechnology and Neurorecovery. Thanks.
Thanks, Theresa. Good morning, and thanks also so much to Caroline, to Dana, to Kara online. Not sure where to look, but hi, Kara, and to of course to Nino. It's so great to be here this morning. I think in part I'm here to demonstrate one of these neurotechnologies, and to hope to prompt some thought about what these neurotechnologies will be able to do in the future, and the many questions that arise at the border of ethics and neuroscience as a result. So in a moment, let's see if I can go back one. No, that's okay. We're gonna leave it right like that. The person kind of behind the words there is a gentleman in his mid-40s with bulbar onset ALS. You will in a moment hear his voice. He is a participant in our ongoing BrainGate clinical trial, and he's using an implantable brain-computer interface. And as he attempts to speak, you'll hear his profoundly dysarthric speech. You'll then also see some words appear on the screen. Those words are the result of the decoding of neural activity with arrays implanted in the brain. And you'll see those words appear not from what he's speaking audibly, but from the neural activity itself. I'll say a few more things about that in just a moment.
Hello, is this on? I have been waiting for this for a long time.
One more.
I want to continue talking to you.
So this is some fairly recent great work being done by our BrainGate colleagues at the University of California, Davis. And on the left there is the actual order of phrases that our participants spoke. And I'd highlight that second and third phrase, and the rest of it. He said, "I'm looking for a cheetah." This is to somebody who thinks about decoding neural activity is probably an error. There's no way that somebody's talking about looking for a cheetah when they're using an implantable brain-computer interface, except for the fact that his 4-year-old daughter had just walked into the room dressed as a cheetah. And the rest of that conversation is really in the context of the first sort of verbal conversation between dad and daughter. She had been diagnosed about 4 years earlier, right around the time she was born, in a way that she's going to be able to remember, and that and with her responding and him attempting to say things, and his words coming out in what is ultimately a audible deep fake for good. That's a version of his own voice prior to the onset of ALS. So I mentioned this, and this is really just one of many examples of the potential that implanted brain-computer interfaces will have to restore communication, to restore mobility, to restore autonomy and independence, to restore some of the abilities that, given a diagnosis, whether it's in the neuro ICU in the clinic or in the clinic, may not have been predicted at that moment in the ICU or in the clinic. So what are we going to do with this information? What are we going to do as a society with this potential? What else is hiding sort of in the neural activity that we're recording? We're decoding information about attempted speech, but there's a lot of information in neural activity. Is there other stuff in there? And if there is, how do we try to explain what that stuff is to somebody who might join a clinical trial or might use one of these devices? How do we ensure, to the extent that it's appropriate to, how do we ensure the privacy of that information that's being communicated? How do we make sure that the access to these extraordinary technologies is going to be wide and equitably distributed? There are so many questions that this and many other neurotechnologies raise. That's one of the many reasons that we're all gathered here today, and I'm really looking forward to that discussion. Thanks.
Thank you so much. Our next speaker is joining us virtually, also on call, taking care of a traumatic brain injury patient. So Dr. Williams, thank you so much for being here. Dr. Williams is an associate professor of neurosurgery at Mass General Brigham and Harvard Medical School.
Yeah, thank you so much for having me. It's an honor to be here, and I really thank the Dana Foundation for everything that they do. So that, like Dr. Williamson said, I'm a neurosurgeon here at part of the MGB. Very interested in neurotechnology and in part some of the intersection between neurotechnology and neuroethics. And so, despite this growing understanding of how the human brain works, there's still really not a lot that we really know about how it works. And when you think about it, the brain, for most individuals, has up to 80 billion individual neurons that work together to create things like language and thought. This is 80 with 9 zeros to it. And to try to understand how this all works together is really a big challenge. And so one of the things that we've been really interested in doing over the past several years is to try to develop technologies and adapt them in ways that allow us to start peering into the human brain and trying to understand how do we do the amazing things that we all do. And so over the past few years, we've adapted this technology. It's called the Neurotech probe. And essentially what it is, it's a hair-thin probe. It's a linear silicon microtransistor, essentially, that has up to 1,000 little contacts on it. And as part of certain neurosurgical procedures, we can temporarily put it in part of the brain, on the brain surface, and essentially listen to what the brain is doing as we have participants, do basic things like speak or listen, or do more complicated things like trying to predict what somebody else is thinking, for example. And we try to do this in a very structured and ethically guided manner. So these are individuals that are undergoing neurosurgical procedures like deep brain stimulation for things like Parkinson's disease or tremor. Whereas part of the embedded neurosurgical procedure, they're already going to have some kind of recordings. And so for a very brief time period, we'll listen into what the brain is doing and then move on with our task, or maybe move on with a general. So the really interesting things that we've been able to find, and one of the things that we've been very interested in, as Dr. Hochberg alluded to before, is how do we produce things like language? And when you think about it, this is a really complicated thing to do. So even to say a simple word like tiger, for example, you have to kind of like conceptualize that. You have to retrieve the semantic representation of that particular word. You have to take the individual phonemes, so the individual sounds that are all glued together, and put it into a word in a particular syllabic structure and form. But at the same time, as I'm speaking to you right now, you're able to kind of like grab all these individual sounds from thin air, glue them all together into words, and understand what it is that I'm saying to you. So this is, it's a pretty amazing thing when you think about it. But what the basic, computational units, what the neurons, what the individual, ones and zeros that are happening in your brain as you're doing this, it's not really well understood. So this is kind of like a first step or an early step in trying to understand how do we do these human unique, how do we have these human unique abilities? And another goal is really to build on this to better inform the development of devices like brain-machine interfaces, similar to the amazing work that Dr. Hochberg just presented. How do you use this information to better create neural prosthetics that are able to treat individuals with lost function, like motor function or speech or thought or even memory? So this is kind of like an early step, but again, I really appreciate the opportunity to just show you some of our work and some of the things that we're interested in. This is a great forum and group to do this in, so thank you.
Thanks so much, Dr. Williams. Our next guest came to us from South Carolina, Dr. Nathan Rowland, who's a neurosurgeon and associate professor at MUSC. Thanks so much for being here.
Bands. Thank you, Theresa. Thank you. Let's see, I advance there. All right. So I am so delighted to be here. I'm so delighted to have been asked to come. This is such a distinguished panel. I'm not used to being next to folks of this caliber. So I'm just thrilled that I was asked to come. And of course I said yes. I'll be very brief. So I remember when I was an assistant professor and I was just sort of getting started. I trained as a functional neurosurgeon. So like many of the panelists have already talked about, my training is in deep brain stimulation for Parkinson's and many other chronic neurological conditions. And so we went to the Medtronic headquarters in Minneapolis, and they sat us in a room sort of like this. And they have this huge screen that was from wall to wall, is huge and very impressive. And they said, these are all the places in the world that we do deep brain stimulation. And basically, they were all in North America, and there were a few other dots throughout the world. And I'm sure I was the only person there. First of all, I was the only person of color there, but as the only person to focus on the places where they were not doing this, that had no access. There was one place in all of Africa, one place in all of Africa. There was maybe a place or two in India, and the rest of the world was totally blank. And so while everyone else was focused on where this was being done, and by the way, deep brain stimulation is an amazing technology that I use every day, so I know its benefits, there are so many places that don't have access to this. So my career sort of went along the kind of normal trajectory, research lab, K awards, all those sorts of things. And then things really took a turn when I took care of a patient with traumatic brain injury. She had a very severe traumatic brain injury. She did well. Her parents were very grateful and provided an endowed chair for me in functional and restorative neurosurgery. And at that point in my career, things really changed because I had to not think just about deep brain stimulation in my own practice and even my own lab, but a lot broader in terms of who can I infect, how can we build a mission, very similar to NJAM, by the way, around practicing, teaching, and exploring brain science, which is the mission of MIND, which is the MUSC Institute for Neuroscience Discovery. And so I began to think about how can we take this technology all over the world. Some of the images that you're seeing on the screen are me really trying to delve into how do we do this? How do we do this in different cultures? How do we go around the world? What do we focus on? Chronic stroke became one of my many foci. And currently what we're doing, and endowed funding is very different than grant funding, I found out. So, it's opened up a lot of doors for me to be able to do some of this work outside of the traditional grant mechanisms. Having said that, a lot of what we're doing is very similar to what Lee does and what Dr. Williams just spoke about, but trying to use off-the-shelf technology, kind of using the SpaceX model, which is more sort of already FDA approved equipment or tools and techniques for other indications, and being able to use them in the way that someone in a third world country would be able to easily access. And so we are on that mission to do that. I can speak about that more during the panel, but they involved things like what we use already for epilepsy, what we use for DBS, but in a kind of a different way, using machine learning and AI to be able to try to reduce some of the manpower needed and some of the infrastructure needed to make these machines and technology work. So I hope that was a little bit of just a kind of a summary and intro to what our institute and our organization does. And again, thank you so much for the invitation. This has been really fantastic for me. Thank you so much.
Thanks so much for being here. I've looked up to Dr. Rowland for a long time. When I was a medical student, you were a senior resident or chief resident when I was doing my sub-internship. So it's really awesome to have you. Our last guest on the panel is Dr. Shreya Srinivasan, who's an assistant professor of bioengineering at the Harvard School of Engineering and Applied Science.
Thank you so much for having me, and good morning. Pleasure to be here. So my research journey started in developing neural prosthetics, and and these human machine interfaces that really interface the nervous system outside of the brain. So we're talking about things like prostheses for the limbs, and it's to basically replace sensory motor function. And we dove deep on, there's a lot of really nice devices out there. DARPA spent many millions of dollars building the Luke arm and Theka arm that have 32 degrees of freedom. The wrist can rotate 360. But if you actually talk to patients that use these devices, after about 2 weeks, they're a nice shelf piece because they're very hard to actually communicate with and use. And one of the biggest challenges is you don't get sensory feedback from a lot of these devices. So as they're moving, you have to constantly visually follow what's happening. And that's just too cumbersome and it takes too long. At conferences, I would often notice that the patients that would actually demonstrate these technologies, if you see them eating lunch, the arm has come off and they're eating with their residual limb. And I think that was the true test and an eye-opening moment for me of, does this actually work and help the patient? And so in a somewhat non-standard engineering framework, we actually thought about redeveloping the surgical process to reconnect the nerves and the muscles that provide sensory feedback at the time of amputation. So not just designing the actual robotic technology, but redesigning the body itself such that it is able to provide and receive signals. Now over 75 patients have had this. I don't know if this movie will play, but over 75 patients have had this type of surgery and are able to have much more improved sensory motor function. They have reflexes, but most importantly, they're able to feel what that limb is doing, how it's moving in time and space without having to follow it. So that's where I started my journey. And then as I progressed, I came across this very exciting field, which is the enteric nervous system. How many of you are familiar or have heard of the enteric nervous system? Right. So consisting of 400 to 600 million neurons, this is the nervous system that lines your canals of your gastrointestinal or GI tract, all the way from your mouth, all the way to the anorectal canal. And the enteric nervous system, or the gut brain, controls everything from your mood and your hormones to your metabolism and your digestion, how you feel. Lots of emerging research is showing that it is really an early biomarker or a pathway for the development of diseases like Parkinson's, anxiety, depression. What you eat is how you feel, and that statement has a lot of weight to it in a scientific context. So we started developing these devices that are ingestible bioelectronic pills. So you swallow them, they travel to the target area in the stomach or the intestines. They're able to sense the environment, say temperature, pH, motility, and then electrically stimulate, for example, to improve something like gastroparesis, which is where your stomach is paralyzed. And by talking to the neurons and stimulating them, able to recreate the peristaltic contractile waves that push and process food down the tract. We've also developed another pill, which is quite fascinating to me in terms of its mechanism, that mechanically stimulates the tract and is able to activate specific mechanoreceptors that line this enteric system that actually tell you when your stomach is distended or full. And by swallowing one of these, our swine are able to eat about 40% less food because they feel satiated or illusory satiety much earlier in the meal. And so I think we're just at the tip of the iceberg in terms of unlocking the true potential of the gut brain and being able to modulate the brain's activity via the gut, which has so many connections and is also interconnected to so many other systems in the body. And so I think in terms of the future of neurotech, there's really quite some exciting possibilities out there to, first of all, restore function in many cases of disease, but then start to push that boundary of actually augmenting function or monitoring it in healthy folks. And so I think the possibilities are really endless and exciting, but that comes with a lot of questions on safety, feasibility, ethics, who gets access to this. And especially as AI enters the realm here, there's a lot of questions of how we must, as engineers, kind of ethically shape our development to think about how this will pan out in the decades to come. So happy to discuss more, and thanks for having me again.
Well, Well, thank you so much for that wonderful panel. And I just want to let the public know that we have 2 microphones so you can ask questions. We'll have about 20 minutes for questions. And I'll get them started, and I'm sure you will have a lot of interesting questions for this panel. So let's start with this. What would be, and based on each of the technologies, right, that you were talking about, what would be the biggest barrier right now for the technology that you discussed in order to help increase access to patients? So biggest barrier, and then if there is one policy change that you could make, and hey, this is your chance. What would it be, and how do you think it would help promote access to these technologies? So who wants to start? I see Elena with the microphone in her hand.
Well, I guess one of the things that I would say, and it's not anything we talked about, but it is a related technology, and that is neuroimaging and cognitive motor dissociation, which was a paper that Elena was the lead author on, published last year in the New England Journal of Medicine, that found 25% of people who appear in the vegetative or comatose states actually have covert or cognitive motor dissociation. So one of the things that I would want to do, if we don't count you, you don't count. Right? Mm-hmm. If we don't know you're there, we can't do anything about it. We can't do BCI, we can't do DBS, we can't give you amantadine, we can't do any of the things that might make a difference. So if I were brain czar, right, what I would do is to have a kind of surveillance mechanism where we actually were going out there and making sure those people were known to us. And then the second thing, the barrier though, is not every hospital has a cyclotron to do an fMRI. So I would be exploring, and there are people like Jan Clausen at Columbia and others, and the Curing Coma campaign, for example, that is looking at ways to take low-tech technology like EEG, which addresses your problem, where every hospital in the country and in the world has an EEG machine to do the electroencephalographic surveying for cognitive motor dissociation. And then you'd send your data into some algorithm at a fancy academic medical center that could say this person could have CMD, cognitive motor dissociation. So I think that there's a creative way of doing it, but there's no will there if there's no will there, and it has to be a priority. And I think the study that Elena took the lead on turned CMD from like a little issue that some of us were worried about to a public health crisis. At least 25% of patients have covert consciousness, and they're in the room and nobody knows they're there. That's a big problem.
I'll piggyback on that.
Please.
I'll piggyback on that. So I agree with absolutely everything you said. And I think we have to pair it though with the so what. So now we have found that somebody has cognitive motor dissociation. What does that mean? How do we access that cognition to be able to give them autonomy, restore their identity, and ultimately gear our studies towards getting people to that minimally acceptable outcome that would make it worth it for them to be in a condition where they physically appear to be unresponsive, but internally are processing and understanding the outside world. So I think for every study that we have that pushes these technologies and uncovers these technologies, they have to be paired with a study that understands how people respond to, process, and what people want out of these technologies.
I'll follow first by making, if I can, both Joe and Elena co-brain czars.
You got new title.
Karina, just to be clear.
Given permission, so there it is. The so you asked for challenge. One challenge, I think you said barrier, but I'm going to morph that into challenge. Is that we really do want to see all of these pilot and pivotal clinical trials happen. And it's hard, and it's hard for a good reason, but we want to make sure that there is both public and private financing available to make sure that all these great ideas get tested rigorously and then eventually become available to be prescribed and available to the greater public. In terms of policies,
for the brain czars.
For the brain czars to approve as soon as I say it.
Working on
it. It is, I think just as Elena said, these technologies could be extraordinary, and we somehow have to try earlier to see if they're going to work than we currently have the will to do. So that's not necessarily a policy change, but there is great, appropriate, conservative approach that is taken over and over again to saying, gosh, that technology could work for X. Just to give one example, there are any number of parents of children with severe neurologic disability who have seen the kind of hallmark demonstrations of implantable BCIs. And those parents have said, where are you as a field? And we say, well, we got to wait. Do we have to wait? Should we wait? There's good reason to hesitate, but I think we really need to explore that discussion a little bit more, not only for children who may benefit from these technologies, but this is just being discussed for people who we discover may have more awareness than we were previously aware of. And how do we unlock that?
Yeah, that's fascinating, and something that some in the public may not be aware of is that things like deep brain stimulation are used with children, particularly with dystonia. So that's a really interesting aspect to explore with these invasive neurotechnologies. Dr. Roland.
Can I be one of the brain czars?
Yeah. we got three. This is great.
Why not?
As long as I'm not, just keep it.
I think what you're asking is, in my eyes, from where I sit, multidimensional. So we're thinking about the physiologic processes that go on and how do we decipher brain states of consciousness. And then where Lee sits, he is really kind of the best person, at least that I'm aware of, on this panel in terms of how to structure multiple clinical trials all around the country, around the world, to achieve a single kind of mission, which is to understand how a technology impacts human brains with various diseases, chronic diseases. And so that's a huge challenge. That's it's infrastructural, it's personnel, it's staff, it's funding, and all those sorts of things. For me, where I sit, it would, again, going back to my opening remarks, thinking a little bit, just kind of broadening our scope. And part of what NJAM's mission is to connect the dots. For example, yesterday I had, series of meetings, kind of like a normal day for me. And then the very last meeting I had before I got on the plane here was an M&M set up by a group in Africa, I think it's Ghana. It's a neurosurgery group that just does M&M with people in the US. I have zero idea how I got added to this. It just appeared on my calendar one day. I clicked on it and they were just describing some of their traumatic brain injuries, what happens. It was fascinating. I didn't even say anything. I just listened because I just wanted to learn. I think, and there's just a lot of education for me to learn how what we're discussing affects people who also deal, probably even more so, with traumatic brain injury issues. For example, I was in India maybe a couple of years ago. I had no idea that I was at a trauma conference there, neurotrauma. And I thought, oh, that's, I guess like a small niche of what we do here, but it turns out everything is flipped there. That's their main indication for neurosurgery. I didn't know that. I didn't realize that because of the lack of helmets there, that more people die of neurotrauma than any other neurosurgical indication, and that their main barrier there is simply just getting like sort of public messaging out for wearing helmets. That's such a low cost sort of thing that we would think about. So, and when you look at I think it's the Lancet study, if I'm not mistaken, that was published and then updated maybe a few years ago on traumatic brain injury worldwide. I guess I didn't realize it in the US and in what they call first world countries, the highest cause, the most prevalent cause of brain injury are falls, but in third world countries is trauma. And I didn't understand that. And so I think we just have to kind of keep in mind what the rest of the world is doing in terms of how we develop and strategize and conceive of science and physiology and technology and biotechnology and how that affects the rest of the world. And that's kind of where we're sitting. And the reason that's on my mind so heavily is because at our recent conference that we had, we started off with just Charleston, which is just such a small city. I mean, it's like nothing on the map. And everyone said, well, who's going to be interested in that? And then we got some people from, I think it was maybe Canada that got interested and they signed on. So, okay, fine, we'll do Zoom. And it was super expensive. We said, okay, that's just not worth it. Well, let's try it. Let's see what happens. So we just paid an enormous sum to have this conference video live stream, sorry. And then some Mexico, then there was Australia, then it was Oceania, then it was Africa, then it was Asia. So we had basically 6 continents and 17, 18 countries that were live streamed into this conference. And it just showed me that there are all the things that we're talking about. Everyone in the world wants to listen in on what we're doing. It's so interesting to them. You all are thought leaders and subject matter experts at traumatic brain injury, states of consciousness, biotechnology, the enteric nervous system, which we had a talk on the gut-brain axis and how to maintain health, because that's what people were asking that. They're so interested in the subject. And so I just think we just have to kind of keep the rest of the world and how what we do changes that. But we are all one, right? We're all connecting the dots. And in my opinion, the bigger the world gets, the smaller it gets. That's just, I mean, just who, John Duffy, raise your hand. Yes. I walked in the room and within 5 seconds, I figured out he went to high school 5 minutes from where I live. So it's just such an amazing illustration of what we're talking about. So anyway, that's how what I think the biggest barrier is just our thinking, sort of teaching a lot of education around what other cultures experience, and then how can we integrate what we're doing with what their needs are.
I don't think this is a particularly novel thought. Obviously, funding and infrastructure, I think, are huge challenges to getting out technology that is especially, on the edge for a population that is where the unit economics always don't add up in the initial years in the first decade. And so investment from a commercialization standpoint is tough because the ROI is not quick. And the other challenge I see with translation of technology and how policy kind of shapes this as well is, here in Boston, we are so privileged to have such interdisciplinary training centers and collaborations. If you just step a little bit into the Midwest, for example, that changes. And then if you step beyond the United States, I mean, I do some global health work and the drop-off is quite significant. Technologies like prosthetics do take interdisciplinary teams of surgeons, engineers, physical therapists, occupational therapists, like all working together to really make it happen for the patient so that they can take it home and use it. And that kind of infrastructure is lacking at most places. And even here at top tier academic institutions, it's a challenge to put those together and sustain them with funding and the resources and the people. So some sort of a pipeline to make that happen at more places, I think, is really critical to bring this tech to life and to patients.
Great. Thank you so much. Dr. Williams.
Yeah, no, these are really interesting comments. I will say, within the field, and part of what I practice is functional neurosurgery, which is essentially treating individuals with neurotechnologies for conditions like depression, Parkinson's disease, OCD. What I find, and I think, which is kind of like one of the biggest challenges, is that the amount of patients that we treat is far, far smaller than the number of patients that need these neurotechnologies. Part of it is access, and part that this was pointed to earlier. But I think one of the biggest questions is how do we make this available, but also how do we make physicians who treat patients aware of these technologies? A lot of them are fairly recent, so really within the last 5 years, for example, we've been using new techniques like vagus nerve stimulation for treating patients with stroke. So these are patients with paralysis. And oftentimes people with strokes just feel that this is how it's going to be. There's not, beyond like some physical and occupational therapy, there are not many options. And there really is. And then I would say more saliently, and Lee Hochberg alluded to this, is we also have a lot of emerging technologies. And I think sometimes we're a little bit afraid to use them. We're very ethically, we're very cautious about, when do we introduce these technologies? But when you think about it, Dr. Hochberg, for example, just showed this amazing video of a patient who is essentially anorthric and able to speak with technology, but in the whole world, there have been just a handful of these placed. So how do we introduce these? How do we make people aware? I think that is one of the biggest challenges. I think would be very topical for this group to try to address.
Great, thank you so much. We have a question here in the audience.
Hi, my name's Elizabeth Guggenheimer, and I'm a member of the public. And I'm here because I'm interested in the subject, but I've realized that I know a patient for whom this treatment might be really extraordinary. I think Dr. Rowland and Dr. Williams talking about stroke. This is a young woman who at the age of 22 had a very severe stroke. She had just graduated from college and she was married. And 8 months after her wedding, it turned out that she had an AVM, which led to a stroke. She has the most supportive family and community in the planet. She lives in England. She's now home with her husband. Her house has been adapted for her with her disability, but nothing in the world would make anybody happier than if she could get some kind of treatment which would restore more of her function. And so my question is, how do you connect a patient like that to potential treatments? And I'd be happy to talk to anybody about this at any time during the day, because this is like, you know, she's in my family circle. She's a very, very, very close friend and a brilliant, brilliant woman who her family recognize her now, you know, as being the person she always was, but clearly she's very distressed by her own disabilities. So thank you.
Thank you. So any thoughts on how to access some of these? Yeah. Dr. Rowland first, and then Dr.
I was going to let Dr. Williams also, if he was mentioning that question. If I understand correctly, I just want to make sure this is a patient that had a stroke, right?
Yes.
I would just say for me, because I do this every day, it would take me all of 5 minutes to get in touch with her, get her scheduled, get her ready to come to surgery, and she'd be having surgery next week. So if you just want to give me her name, I'm happy to do that. If it's for emerging technologies and being enrolled in clinical trials, I'll let the others speak to that. But I have a very good relationship. That picture that was shown in my opening STEM, I guess, remarks, was a picture with me with the Vivistem company, and that's what Dr. Williams was referring to, vagus nerve stimulation for a stroke. I did the first case in all of the Carolinas, and that's the part of the stroke belt, of course, and so we have lots of patients with stroke. It would take almost no time for me to talk to her. I could talk to her today, like within 5 minutes.
You got it.
Dr. Hochberg. Thank you.
Ziv, do you want to jump in before I?
Oh, no, go for it. I'll follow.
Yeah. So thank you for your question and for making us all think about a question that is so key to why we're here. How do we make sure that everybody who could potentially benefit from any of these neurotechnologies knows about it, has a way to find out more about it, and then eventually has access to it? This will briefly become an advertisement for Mass General Brigham. And it wasn't my plan when I stepped up here, but so at Mass General Brigham, we've opened a brain-computer interface clinic, which is really part of a neuro recovery clinic. And it's just an example of, we have all these technologies that may be able to help, for example, your friend and many others with neurologic disability. But knowing that those technologies are available and which of those technologies are the right technology for any individual patient is sort of an emerging specialty. How do we figure out, given an injury or disease, what are the right, from the palette of options that either are available or will become available in the next 5 years? How do we make sure that the right patient has the right technology at the right moment? And I believe that there will be a growing number of these types of neurorecovery, neurotechnology, brain-computer interface clinics that are established, and similarly happy to connect with a person who you know so well, and see if we can have that initial conversation. And even if there's not something today, which there may be something in the next 2 or 3 years, and we need to make sure that we can reach back out to the people who will benefit from these technologies.
Great. Thank you. Dr. Williams.
Yeah, I'd say one of the good things is your friend probably has a lot of good friends here that she can reach out to at this point. Yeah, I think all of these are really important points. And what I've found personally is that a lot of patients will search out, they'll seek out individuals. A lot of this is on the internet, looking at what trials are available, what services may be available. But I'd say for most patients, it's a really opaque process, and not everybody is very tech savvy, or I'd say even Google savvy. How do I find the right people? So I think part of this is really incumbent on us. How do we advertise? And I don't think this is necessarily a bad thing. It is important to advertise these services, but in a way that is accessible to a broad public. And I don't know that I have the right answers for this. And I think one of the early steps that we've tried to do is to create these centers that offer these options, and like Dr. Hopwood said, also do our part in telling or basically triaging individuals to the right technologies, the right treatments. I think there's a lot of work to do, and I think outreach is one big part of it, beyond just the science of it and the technology development.
Great, thank you. So we'll take 2 more quick questions, and then we'll continue the conversation during the break. And for those who have questions in the chat, we'll try to get them as soon as possible.
Yeah, let me just give one of the questions from the chat. Thanks to all of our Zoom participants. Maybe Dr. Srinivasan, you could take this. You mentioned working with industry, and the question is, how can we ensure robust regulation over brain interface companies? And I guess the flip side of that, while also promoting innovation and investment in this space and moving quickly, but not too quickly.
Yes, it's a great question. I think it comes up quite often. The shortest answer I can provide is that it really does involve training folks and educating them with a interdisciplinary and holistic framework, such that when they're on the industry side, for example, they're still thinking about some of the things from the flip side, right? Where profit may not cloud their judgment. I do think there is a need for us to think about regulation and some legal framework for oversight in the decades to come. But again, I think collaboratively, I think as you are having these sorts of discussions will really help frame those guidelines and regulations and policies in the years to come.
Yeah,
I'll just add quickly, and thank you to the Zoom audience for the question. I can provide some assurance that the current neurologic devices group at FDA is really extraordinary. And as a public, we can be really proud that there are people there that are well trained in neuroscience and biomedical engineering and neurology and neurosurgery and other related fields that are helping to navigate this emerging set of neurotechnologies, both the ones that currently exist and are being used in new ways and the ones that are being developed. And they too, along with the rest of us, are learning how these technologies will work, what the risks may be, what the benefits may be. And I think to the person who asked a question, to the heart of your question, is because the field is moving so quickly, there's also an opportunity through, for example, a collaborative community. There happens to be a collaborative community in implantable brain-computer interfaces, which is the ibci-cc.org. It's my second advertisement of the day. But what is critical to achieving the types of regulation where there may be holes in regulation right now, that is holes in actually written down code, is to make sure that, for example, people with lived experience of paralysis or neurologic disease or injury are available and are part of those discussions now, as this regulation and the policies that inform them are grow and expand in the years ahead, as well as patient advocacy organizations, engineers and academic researchers, and the industry, the number of industry partners who are thinking deeply about this as well, and making sure that their technologies can not only achieve their goals, but can do so as they must within the regulatory framework that exists today.
Thank you.
And maybe,
oh, sorry.
sorry, if I could just bounce off of that, actually. I think the news media sometimes sensationalizes the neurotech as like hacking into the brain and hacking into the body. And yes, that sounds nice and it's a good, thing to click on. But truly, these devices are quite far from quote unquote hacking the body, and are very well regulated and indicated. And so I think the current use cases are rather safe, and there's been a lot of science and engineering and work done to make sure of that. So
thank you. So let's take, one more question, and then we'll continue the discussion during the lunch. Yes.
Barry Roth, I'm a psychiatrist. This has been extraordinary. I have 4 psych boards and an addiction medicine board, and this is just so above my pay scale. But by way of isomorphy, things working together, and I think this is relevant. It's a issue I struggle with, and I'm interested in whether you would wish to respond from your side. And that is the elephant in the living room. What's our proper role today? I hear justice, social justice, we're all in the same boat, and the rights to the rule of law, fair wage, a safe home and environment must be and are interdependent and universal and non-derogable, meaning they can't be dismissed. Accessibility and accountability have been concerns for decades and generations. So the question is, within our role, within the role standing in the ground where you have spoken from, objective, evidence-based, scientific, neutral and impartial, what can we say or what should we say? And my particular niche is torture survivors applying for asylum, and I make the point that I am not advocating, when my job is done properly, the facts speak for themselves. So what do we say today?
So,
yeah, I was just going to speak to that briefly. I think it's a really great question to end our panel on, because I think it talks about just the society that we live in at large, right? If I'm understanding the question correctly, and there's so many things that are, we consider to be rights that are still challenges in terms of people having access to all of them. And then what do we do now that we have this really quite advanced technology, quite expensive technology that not everyone has access to? How do we advocate for that? And then also advocate for the societal piece, which is, I think, something that probably keeps a lot of us up at night, because the reality is we can do the fanciest surgery. If the patient has nowhere to go after they leave the hospital, or if there's no access to the rehab that the patients need, that did so well in Dr. Bodin's study, for example, then have we really won it all? Or if there's only a certain subset of patients that can get access to these things. And I think, in order to get some sleep, which is important to me, the way I get myself through that is thinking about, sort of creating more of a movement than of one center, of one place doing this work, right? So our trainees are here. They're going to go out and lead somewhere else. They're going to go out and be in that boardroom with that policy and be able to remind people like, yeah, that's super cool, but what about our patients that speak a different language natively? Or how are they going to be included? How are we going to make sure that we have this technology? Or think about the EEG idea, like data is transportable, right? So why can't we bring, the data from an EEG to somewhere else and then use transcranial magnetic stim or something instead of an invasive implantable for certain patients? And how can we match up those societal factors? And I think the reason why I'm really proud of our trainees and that they need to be really sophisticated in this is that there's opportunities for bias in doing that as well, right? So we don't want to exclude people from these technologies by saying, oh, well, it might not be good for them, right? Because I think we've already been all too good at doing that in medicine. And so I think we're here to try together to sort of raise the tide so that so many of our patients can benefit from these technologies.
Gabe, can I just make one quick comment?
Yes.
So just
One
follow
last
up
comment and we'll
on
wrap
what
up.
Theresa
This
said.
is a wonderful discussion, but we'll continue during the break. Yeah.
I'm writing a biography of Lewis Thomas, and he had this phrase, about halfway technologies. And he said, the iron lung was a halfway technology for polio. Then we had a ventilator, and then we had vaccines. And I think we have to appreciate that we're really talking about halfway technologies. And when Theresa says, maybe transcranial magnetic stimulation is less invasive and more accessible than DBS, or we have, enteric pills that we can take, but the point is we're only halfway there if we continue on the journey. So I think the most important thing is to maintain the work and the science so that the work continues, and what seems advanced now will seem primitive in the rearview mirror.
Dr. Roland, yes.
Oh, I'm sorry. Thank you very much. 30 seconds. I have had this argument with my leaders for so long. When we started MIND, MUSC Institute for Discovery, they said that is so stupid. Who would want to do that? That no one knows that. That makes no sense. But my argument is that we are never inspired by institutes themselves. We are inspired by discoveries. And so our role in society is to discover. That's our role. That's our role. Because why do institutes die? Because institute is not a verb. Discovery is a verb. So that's our role. It's just to continue. And all of these half, quarter, and then full inventions will eventually get us there. But our role is just to continue to be inspired and curious. And so I hope that answers your question. But this is something that people will fight against. They will say is not needed in this current day society, especially with AI, et cetera, et cetera. But I think that's the one thing that makes us uniquely human. And I think that's what our role is to continue to dispense all of these great inventions and ideas, and then to come up with the next generation of those.
Thank you so much. Thank you to the panel. Wonderful panel. We'll take a 5-minute break and then we'll be back here for the next panel at 10:30. Thank you.
Right, let's get going. Exciting day and amazing panel. We move now from the clinic to the courtroom. My name is Francis Shen. I have the pleasure of co-directing NJAM with Dr. Williamson and Dr. Lázaro-Muñoz. And I want to say just 3 things at the start, and then I'll introduce our panelists and you'll hear primarily from them. First thing is a really big thank you again to the Dana Foundation. The Dana Foundation is one of the few and perhaps now the only funder who has the foresight to fund and generate new work at the intersection of neuroscience and law. They've been doing this for decades in terms of training judges in neuroscience. And obviously, as you've heard today, they're doing it with this new training program. So thank you to the Dana Foundation for all the work that you're doing. Second is, I just want to emphasize a theme that came up in Dr. Williamson's last comments, which is about the importance of partnerships. NJAM and our work at the intersection of neuroscience and law is facilitated by a tremendous number of partnerships. And so you're going to hear from just a snippet of it, but even in the next 40 minutes, you're going to hear about the Center for Law, Brain, and Behavior. You're going to hear about the Petrie-Flom Center for Health Law, Policy, Biotechnology, and Bioethics at Harvard Law School. You're going to hear about applied work in the Suffolk County District Attorney's Office, our community partner, More Than Words, the Flashner Judicial Institute, and I could go on and on. So I really want to thank all of our partners, those who are here today, those who are with us virtually. And then finally, I just want to emphasize that as important as neuroscience is for the clinic, and that's what you usually think about, hey, new discovery in neuroscience, that's good for brain health and brain challenges. And that's true. Turns out that it also has an enormous number of legal implications and for the administration of both civil and criminal justice. You don't usually think about those, but NJAM does, and this panel today is going to tell you a little bit about what we're doing. So our program today, we have 4 panelists. I've challenged them to limit their remarks to 7 minutes each, which means we'll have a little time for discussion at the end. Our first panelist will be Susanna Baruch. She is the Executive Director of the Petrie-Flom Center for Health Law, Policy, Biotechnology, and Bioethics. We recently had the pleasure of working together on a conference that you're going to hear about aging brains, aging brains, developing brains, and everything in between. Full bios are in the links on the website, so check that out. And let me invite our Harvard Law School collaborator, Zena Baruch, to the podium.
Good morning, everybody. Thank you for inviting me. Thank you to the Dana Foundation and the organizers of today. So I want to start with what is, you may ask, the Petrie-Flom Center for Health Law Policy, Biotechnology, and Bioethics, and why is its name so long? So we are the Health Law Research Center at Harvard Law School. This is our 20th anniversary year. And I like to say that our long name says it all. Our mission is to promote interdisciplinary scholarship and analysis, connecting law, health policy, bioethics, medicine, bioscience, and biotechnology. And I want to talk a little bit about what the kind of interdisciplinary training in this area looks like from a law school home base. We have one of our former student fellows, recently graduated student fellows in the audience. So I just want to say, hey, I'm going to talk about all the different programs that we have. So our faculty director, Glenn Cohen, is a respected scholar in the field, but I just wanted to mention specifically, he teaches a very popular class that features emerging scholars in health law and bioethics to give law students and other students from across the university a chance to sort of dig into new and emerging scholarship. Each year we host student fellows, not only from the law school, but from across Harvard. We have visiting scholars in a range of topics from around the world. We host postdoctoral fellows and a lot of other programs, public events, online and in person, workshops, discussion groups, and conferences. And we have a very widely read health law and policy blog called Bill of Health. I encourage you to check it out on our website. And while you're there, you can subscribe to our newsletter, which will tell you about all our events. And just to give you a concrete sense, I would say our top topics in the last year or so have included artificial intelligence, specifically the use and regulation of AI in healthcare and medicine, the possibilities and the risks of the use of psychedelics, including psilocybin and MDMA in mental health treatment. We have a robust project on global health and rights with a focus on reproductive justice. And we've done some events recently on climate change and health. But I really want to tell you about where we overlap with neurolaw, neurotech, and neurojustice. So for more than a decade, Petrie-Flom Center and the Center for Law, Brain, and Behavior, which you'll hear about in a few minutes, has had the Project on Law and Applied Neuroscience launched in 2014. The collaboration includes a senior fellow in residence, public symposia, and a law and neuroscience seminar at Harvard Law School. The topics have ranged depending on kind of who's in the senior fellow position and what our mutual areas of interests are, but have included dementia and the law, pain and the law, adolescent brain development, substance use, and the law. Francis, Dr. Shen, was a senior fellow with us for several years. We have a hard time letting him go completely. We have had many other wonderful folks with us recently, including Stephanie Tabashnik, who's a forensic psychologist and attorney, and Caitlin Tabor, a neuroethicist and attorney. Their work is often some of the biggest draws that we get at the law school, because these are areas that law students are very interested in. And as Francis mentioned, we recently held our annual conference on the topic of law, healthcare, and the aging brain and body. Now, in planning this, my first stop was with CLBB for some initial advice, because they're doing a lot of work in aging as well. My second stop was to convince Francis to be one of our co-organizers. And so this happy event happened about 10 days ago, where we tried to bring together scholars. We had about 40 or 50 people in the room. It was live streamed, to look at how law, public policy, and healthcare entities can help create systems that promote the well-being of older adults at a time when more and more people are living longer. We want to sort of ground our work in the context of emerging scientific understandings of the aging brain and the aging body. Lastly, kind of a word on why this intersecting work among our centers is so important. I will say that in a former life, I worked in a more advocacy-ish space, looking at some technology issues like genetic testing and assisted reproductive technologies. And something that's always been important to me, and it's really at the core of the ethos of the Petrie-Flom Center, is for science and discovery to actually work for and benefit like real human people. Sometimes there need to be guardrails, and sometimes society also has to adjust. And that can be a long, kind of slow, hard process that needs a lot of different kinds of people and different kinds of experts thinking about it. So my view is our shared work is to try to build that path forward. I was really struck by the conversation in the previous panel about connecting to new technologies for brain injuries. And I feel like, you know, that panel was like a panel of superheroes is how it felt to me. And the lawyers aren't always the superheroes, but we try to at least think carefully about what the appropriate guardrails are as scientific discovery and expertise sort of move forward. So I'll leave it there. Thank you for inviting me.
Thank you. And I'll call him out, embarrass him. Javier Mesa is with us. He'll be the new NJAM fellow postdoc who will have an appointment and roll over at Petrie-Flom. So really trying to bring together med school, law school, neuroscience, and regulation. Our next speaker will be Dr. Robert Kinshirf, who's the Executive Director for the Center for Law, Brain, and Behavior, CLBB, at Mass General Hospital. I want to give a shout out to our colleagues who aren't here from CLBB, Judge Nancy Gertner, who teaches the Law and Neuroscience course at Harvard Law School, and the co-founders and co-directors of CLBB, Bruce Price and especially Dr. Judith Edersheim, both MGB physicians who had the great foresight over a decade ago to bring together groups like this. And I'll just give you one anecdote that Robert remember. We hatched many of these plans over scones at Judge Gertner's house. You recall this long strategy meeting. And one of the goals of that meeting was to think about training the next generation. And so to see this come to fruition now, and there are other CLBB trainees. Somebody want to raise your hand in the back also. Thanks for being. So it's not just one program, it's a multitude of programs. But we're thankful to Dr. Kinshirf for all of the partnership. He's a national leader in forensic testimony. He spends a lot of his times connecting neuroscience to, as Susanna said, real people's lives in courtrooms, and we're delighted to work with him. And we're going to hear in particular about a landmark case, and we're going to hear first from Dr. Kinshirf, and then I'll introduce Judge Ullman, who was at the center of that case. So, Dr. Kinshirf.
Good morning.
Morning.
Oh, come on, people. I grew up.
Good morning.
Good morning, y'all. All right, there we go. Thank you. I'm Robert Kinshirf, Executive Director. I'm trained as a clinical and forensic psychologist and an attorney. So I'm trying to keep those various parts of my brain talking to each other. And the Center for Law, Brain, and Behavior's sort of mission is to bring accurate and actionable neuroscience into law and public policy. Just very briefly, we have a training component for rising academics, clinicians, practitioners, our research associates program. We also do a great deal of judicial education, legislative testimony, and the like. Our program areas include criminal sentencing, aging brain, trauma and memory in the courtroom. The one that I have devoted most of my time to is the juvenile and emerging young adult program area. And this is what has sort of really kept my boots on the ground, if you will, as we try and apply neuroscience, which I'll briefly recap, to areas of juvenile and adult criminal justice reform, an area which is has a long and tortured history in the United States and many complications. But I think it's an area which is an excellent exemplar of what translational science can do. One of the challenges for all of this is that often academics not only remain siloed in their various departments, but academics also stay siloed at the academy versus the rest of the world. And they have fascinating, challenging, wonderful, engaging conversations with each other, and then they go home. And that, from our point of view, is a lost opportunity to sort of take the science into the world in the ways that we just heard clinically. Now we think about law and policy. So about 20 years ago, 2005, I had the privilege of first sort of saying how this might work when asked to co-author an amicus brief for the United States Supreme Court that was hearing at that time the case Roper v. Simmons. This was a juvenile homicide case. The issue was whether or not the execution of persons for crimes committed under the age of 18 was constitutional. It was a challenge to the constitutionality. That practice still existed at the time. So for those of you that are over 20 years old, at the time, you were alive when it was still okay in the United States to put persons under the age of 18 to death. At that time that the US Supreme Court made that decision, we were one of 3 countries that still allowed execution of minors by judicial fiat. There's always been lots of extrajudicial killings and all kinds of stuff like that, but by judicial fiat under the authority of the state. In that decision, the court essentially used a developmental argument that children are different and braided that constitutionally to the doctrine that the death penalty is different, death is different. And it did so at a time when the neuroscience was still just emerging. We did not have the kinds of research in 2005 about neurodevelopment that we have now, but they instinctively knew that there was something about children that was different, and they used that subsequently in the jurisprudence that I'm sure Judge Ullman will allude to along the way. Over the years, we've been able to sort of put some meat on those developmental bones. We know now that the adolescent and young adult brains are functionally and structurally different than those of childhood or those of adulthood, and that it goes through sort of a programmed progression at the onset of puberty, maturing from back to front. This creates at least some of the turbulence of adolescence. As Leah Somerville, one of our colleagues who's a developmental neuroscientist, at one point was explaining to me, and I love the way she talks to me when she's talking about bench neuroscience and how it translates. You know the tone that adults adopt when they're very patiently trying to explain something that must be complicated for the 4-year-old? And they sort of slow down and they use sort of metaphors to try and get it across. She was explaining to me that it's absolutely developmentally appropriate that at some point in adolescent development, because the frontal cortex comes online fully the last, she said, it's sort of like having a period in your life where you have the motor of a Mercedes sports coupe and the brakes of a Honda Fit. And it's probably metaphorical reach, but it's substantially accurate. We know that there is a process of pruning. We know that it moves from back to front. We also know now with greater specificity that it's not just on a use it or lose it principle that neuronal circuits are reinforced or faded, but also that this is experiential pruning. That is to say, each brain is pruning on the basis of the individual experiences it is having in its individual environment. Now, that's a mouthful right there, but it's also, I think, something we're thinking about, because if that's the case, this also opens up the door for understanding why the same social determinants of well-being are the same social determinants for your medical status and the likelihood of the timing of your death over the course of a lifetime. They are also the social determinants of whether or not you are likely to have the emergence of a major psychiatric disorder, especially those that have a strongly genetic component. The same likelihood that you will become involved in any one of a number of special systems like special education, child protection, juvenile justice, and criminal justice, the likelihood that you will have an encounter with either the juvenile justice or criminal justice system, and if so, whether or not A, your crime will be a crime against a person, and B, whether or not you're more likely than others to come back into the criminal justice system after an initial encounter. Now, I think if we sort of take the idea of experiential pruning and put that into the environment of the social determinants of health, well-being, including criminal career trajectories, that is really a quite remarkable alignment across a number of different fields with a number of different implications. So one of the things that the court observed in the Roper case, and that we were later able to describe neurodevelopmentally, is that this process of back to front maturation, the process of pruning, and especially experiential pruning, creates a period in a human's life, adolescence, in which there is a neurologically based preference for stimulation and novelty. Future reward discounting, meaning that you would rather have $1 now than have to wait a month for $20. That the immediacy of perceived reward, whatever that reward may be. Right about mid-adolescence, the brain is wired to be able to perceive risk. For example, if you ask most 16-year-olds, are you going to be healthy or less healthy? If you're smoking a pack a day of cigarettes, they look at you like that's a silly question. They know the answer to that question. They also know the answer to the question, are you more likely or less likely to have an unintended pregnancy if you're practicing safe sex or sexually transmitted disease? They know the answer to that question. They know the answer about seat belts. They know the answer about wearing a helmet while you're skateboarding. They know all the answers to that cognitively, but they are the demographic least likely to actually engage in the risk mediating conduct, right? So if you just look at all kinds of things, you'll see a spike in adolescence and then a drop off as you enter your early to mid 20s. And amongst the things that we see are things like they're more likely to drown. Even if you control for a practice effect, they're more likely to have an automobile accident. Automobile insurers and parents have known this for decades, but now we can prove it. Right? They are more likely to have unintended pregnancies. They are more likely to self-injure or attempt suicide. They are more likely to engage in criminal misconduct or conduct that could be charged criminally if they were caught, although most juvenile misconduct is not caught. And they are also wired for social attunement, especially in response to peer appraisals. So in both teenagers, in the wild, which is where I mostly study them, or in laboratories, they will engage in more risky behaviors if they are with peers, or they even think that their peers are observing them, or if they even think that their peers will later hear about what they think will be their heroics. Somebody will increase their social appraisal by their peers. It's actually sort of brain-based. There's an area of the brain that in adolescence lights up when they think they're being watched by peers engaging in a lab-based risk behavior. That part of the brain doesn't even light up again after you're about 25 or 30. You just don't care as much about what your friends care about, right? So what this means is that we have, through criminology, sociology, and so forth, we see this kind of developmental burst of rebellious behavior, maybe even criminal misconduct. It's cabined by social constraints. What counts as adolescent rebellion will look very different from culture to culture, with some adolescent rebellion in very communal and socially controlled cultures looking very different than an out of control American teenager, right? But the brain is nonetheless functioning within its own environment and doing so. Here in the United States, we have, compared to some other places, both a higher tolerance for adolescent misconduct, but also when they cross the line, a much more punitive response to adolescent misconduct. So we see this burst of risk-taking behavior as they enter adolescence. It peaks between about 16 or 17 and the early 20s. And then we've known since the 1920s, so this is not a closely held national security secret. We know that most of them will simply self-desist with neurologic development. We didn't know that in the 1920s, we do now. And with the adoption of adult social roles. We knew that in the 1920s, right? And then they self-desist and criminality drops off unless we respond to that criminality in ways that I hope inadvertently, but nonetheless quite effectively, encourages them to continue on with a path of criminal misconduct. The research will also tell us that if you were to set up a system where you wanted to be as wide a net as possible for youthful misconduct and to sustain it for as long as possible, you would want to draw the line at about 18 so you can catch most of them who are about to self-desist before they self-desist, and then have practices that remove them from the normalizing developmental experiences you find in communities, isolate them from their communities, put them into closed environments with adults who never got the social learning memo and have become life course career criminals, essentially, and leave them there for as long as possible. And then when they do leave, saddle them with as much stigma as possible, so it's harder for them to continue with education, get a job, et cetera, et cetera, et cetera, right? So if we were going to set this up on purpose so that we had by far and away the highest recidivism rates, including violent recidivism rates, amongst people who come into early contact with the criminal justice system in any of our peer developed countries, that's what we would set up. And sadly, that's what we have. The neuroscience has played a role in a line of cases that Judge Ullman, I'm sure, will allude to, resulting in the Mattis case, which has, in Massachusetts, moved the age which life without possibility of parole is barred from 18 to 20. There has been some movement in some other states, but what we do know is that neuroscience has been a remarkable tool to get out of the sort of endless, pointless debate on, are you hard on crime or are you soft on crime? We want to hold young people accountable, but can we think about a kind of developmental accountability? The way that you punish a 3-year-old is not the same way you punish a 13-year-old or a 23-year-old or a 33-year-old, right? A good reason to be using this sort of politically neutral approach is to avoid the traps of being hard on crime, soft on crime. But it also affords us a way of thinking about the outcome, because whether you're a prosecutor or a defense attorney, a citizen or a legislator, we all have an investment in public safety. And it turns out that a neuroscience-informed approach to juvenile and criminal justice has lower recidivism rates by far. And over time, is a substantial contributor to improved public safety. And with that, I will turn it to Judge Ullman.
Thanks, Robert. 2 quick things. One, when was the last conference you went to where your 2 panels featured cutting edge neurosurgeons and then a judge? It might have been the 2023 Neurotech Justice Summit. Second point, things happen so quickly. The case you're about to hear didn't exist at the 2023 Neurotech Justice Summit. It's a landmark case that totally changed the landscape of sentencing for young people. You're going to hear about that. And it had to do with neuroscience. Third point, just as the FDA regulates, hey, when is that new technology ready for patients? Judges are the gatekeepers to think about when is new scientific evidence ready for some use in the judicial system. And yet they're not trained in neuroscience. I'm here to talk about that as well. So it's my honor to introduce the Honorable Judge, now retired Robert Ullman. He is former Associate Justice on the Massachusetts Superior Court, a long history as a trial lawyer. He teaches, including at BC Law School, a tremendous experience in the courtroom. And we're going to hear about how that experience met neuroscience in the case of Mattis. Thanks so much, Judge Ullman.
So I don't know if you heard that very quick retired. In Massachusetts, state judges, we have to retire at age 70. So 70 is a youngster in certain other branches of the government, but for the Massachusetts judiciary, we're done. But I've been given 7 minutes, and obviously there's a much longer version of this. I think it's just important to understand that in January of last year, the High Court of Massachusetts, the Supreme Judicial Court, became the first court in the country to rule that life without parole, life without the possibility of parole for 18, 19, and 20-year-olds is cruel and unusual punishment under the Massachusetts state constitution. And I was the trial judge who made the findings on neuroscience that became the factual basis for our high court, by the way, by a 4-3 vote, to rule that this was cruel and unusual punishment. So I think just a couple things, there's not much I can say in this limited time, but one thing that's important to understand for those of you who are, whether you're physicians or scientists or whatnot, law is almost always made through particular cases. And there were two defendants whose lawyers were pushing for this change. Their cases were both compelling in certain respects. Sheldon Mattis, obviously these were murder cases. Sheldon Mattis was involved in a murder. He was not the shooter, but the shooter was at the time 10 days shy of his 18th birthday. So the shooter obviously was eligible for parole after 15 years as a juvenile. Mattis was 18, and so he got life in prison without the possibility of parole. The other companion case, Jason Robinson, at age 19, was part of a robbery where someone else wound up shooting the victim. He was convicted under a theory called felony murder, of first-degree murder, which, by the way, at least in Massachusetts now, the evidence would not support a conviction for murder for someone who did not have the intent to kill and was a 19-year-old just sort of along for the ride of a robbery. Their cases were compelling in certain respects, but obviously the crimes were very serious. I was asked to do this on December 24th of 2021. The Supreme Judicial Court had already ruled 3 times. They'd already rejected the extension of this doctrine to 18, 19, and 20-year-olds. So I got the case, but I figured 2 things. No, they wouldn't have asked me to spend a ton of time listening to testimony from witnesses, including Dr. Kinshirf, make a whole lot of factual findings if they were not at least willing to reconsider their rulings in these 3 cases. I also thought this meant enough to somebody on Christmas Eve to issue this order, which may have been completely irrelevant, but anyway, the odd things the judges think about. So to me, there was a foundational question, given the fact that the SJC had rejected this 3 times, and it was really, had the science of brain development in 18 through 20-year-olds progressed to the point where it provided a reasonable basis to decide whether or not life without the possibility of parole for defendants who were under 21 at the time of their crimes was cruel and unusual punishment. And I decided, yes, the science had progressed. And I think it's, there were 3 reasons for that. One was that the availability and use of, in university labs of structural MRIs had progressed a lot in the intervening 15 years. Second, studies focusing on the brains of 18 through 20-year-olds. There was a lot more on that. If you think about, Dr. Kinshirf talked about how the Supreme Court in 2005 ruled that a death sentence was unconstitutional for juveniles. That was a result of studies in which the juveniles were one group and the 18, 19, 20-year-olds and 88-year-olds were all in the other group. So there really had to be a sort of a new generation of studies that focused on the 18, 19, and 20-year-olds to show the ways in which certain behaviors differed from those of older people. I won't repeat the neuroscience that Dr. Kinshirf pointed out, but that was very important. And third, that just the number, sophistication, and scope of the studies had increased, including one study that had looked at emerging adults in 11 different countries on 5 continents. So I would say that the neuroscience to me was quite compelling. It was very comforting to me that the behavioral science studies, while those they didn't drive the train as much as the neuroscience, but it was also very comforting to see that the results of behavioral science studies by Dr. Kinshirf and many others had led to the same results. So to me, if you have, I'm no expert, I'm no scientist, but if I see very consistent results in two different areas of science, that increases my level of comfort. So I think I would just say one other thing, which is that, as I say, while the neuroscience drove the train, there are obviously other considerations as a judge you're thinking about. And one of the things you just have to do as a judge is just look at the contrary arguments. You know, this can't be a no-brainer. That's a bad pun. I didn't even intend it. You know, if no state in the country has gone this far, and our own Supreme Court hasn't gone this far. And so, there's the argument, like, if you go, the great majority of these crimes take place in a concentrated area of certain neighborhoods in Boston. This is true in Massachusetts. And if you go 3 miles away, to Brookline, to Milton, to anywhere else, the murder rate is very, very low. And so there's an argument that it just can't be, it can't be the 18, 19, and 20-year-old brain that's responsible for this, because there's so few murders by 18, 19, and 20-year-olds. So you look at that, and then, and I'm sure I'm telling you something that most or all of you already know. You look at what are the conditions that are conducive to more crime. They are economic deprivation. They are stress. They are being in an environment, where there is violence around. These correlate not only with increased perpetration of crimes, but they also correlate with increased victimhood of crime. And so really, what you're saying, you have to look at the systemic, and I looked at the systemic result of this. And what you're doing is you are subjecting a pretty narrow group of people, very heavy correlation with economic circumstances and race, which of course in this country sadly correlates very heavily with that. And those are the people that you are subjecting, as 18, 19, and 20-year-olds to a sentence where they will die in prison. And so you put the neuroscience together, some of the other behavioral science, and at least for me, it was compelling enough to make these factual findings, which, as I say, by a 4-3 vote, led our high court to make this groundbreaking ruling. So that's the 7-minute version. So.
Thank you, Judge Ullman. Well, as you heard, the U.S. legal system bifurcates adults and juveniles. So if you commit a crime and you're 17 years old and 364 days and 24 hours and 59 minutes and 59 seconds, you go this path, and 1 second later, you go that path. In Suffolk County, we're really happy to be working with District Attorney Hayden, who saw in collaboration with a number of colleagues the illogic of this, and to create a carve out for emerging adults, those between 18 and their early 20s. But in order for that program to work, and it was launched just recently, you've got to have someone really talented at the helm. And so you're going to meet that person next. That's Ms. Waddy Hanks. He's the intensive care manager for the emerging adult program at Suffolk County District Attorney's Office. One thing I'll say is that sometimes in a panel like this, you might walk away thinking adolescence is a pathology. It's not. And you know that because you and I hearken back to those moments when we were 16. We're like, oh, I wish I could have that freeness, that energy, that risk-taking ability again. Can you harness all of that amazing stuff? Judge Ullman talked about the structural challenges and the systemic challenges, and that's where Ms. Waddy Hanks has lived for the last 30 years. He's worked with every system in the state, the public schools, healthcare organizations. Before this, he worked for MGB and community engagement. He and hopefully NJAM push the community first and push these youth first. And I think he'll talk a little about more than words, one of our community partners. So it's been great to work with you so far, Ms. Waddy. I look forward to a lot more of it. Please join me in welcoming Ms. Waddy Hanks.
Thank you, Francis. Good morning, everyone. It's an honor to be here.
Listen, I'd be remiss if I didn't mention, I owe my job now to many of you and many of your colleagues in this field. You know, through the research and scholarship in the neuroscience field, especially with this emerging adult population, which is 18 to 25. You know, when Robert was up here, he was talking about, you know, that frontal cortex not being fully formed until, you know, adults are 25, 26. And, you know, one of the benefits of having a forward-thinking, you know, district attorney that understands brain development, understands youth development, is we get a program like the Emerging Adult program that I'm lucky enough and honored enough to head up. So like I said, it's 18 to 25 years old. You know, we're really looking at alternatives to traditional prosecution. You know, again, how Robert was talking about, you know, incarceration does nothing for really rehabilitation or, you know, curbing recidivism. You know, I think things are the way they are for very intentional reasons to, you know, incarcerate a certain population, and it's done its job for a long, long time. But something like this program is a chance to really equal the playing field and give some of these young people a chance at becoming a productive member of society, you know? So when someone comes into my program, I've gotten the authority to get their case dismissed. Now, not indictable cases, so not homicides, not attempted murders, but district court level cases. I've gotten the authority to get every charge dismissed minus sexual assaults and crimes against children, right? And I wouldn't want to touch those anyway. When a young person comes into my program, I'm able to, and everything's case by case, I'm able to sit down, do an individual service plan that will address their specific needs individually. And basically, I've got the opportunity to clear out every barrier that's prevented success, and really just let them thrive. One of the biggest things, I mean, when you look at like the base of Maslow's hierarchy of needs, right? When someone grows up in a marginalized community, poverty, you know, different trauma, different, you know, sometimes within the household, it's so hard to achieve success and achieve, you know, becoming a productive member of society. So this program allows me to really look at a young person and figure out where their needs are, address those needs. And it's anywhere from education, career exploration, you know, employment, housing. I was thrilled, and probably my biggest win so far since I've been in this program was to put a set of keys in my second participant in the program's hands about 3 weeks ago. He's got housing now. He's also got a commitment from another partner organization to get financial assistance for the next year. It's on a staggered basis where the organization, and mention the organization by name, Charlestown Adult Learning, Reentry and Workforce Development. It's through a rapid rehousing grant where the director created. It's a staggered pay, so they'll pay 70% of his rent for the first 3 months. Next 3 months, 50%. Next 3 months, 30%. And then after a year, the young person has, well, they'll be expected to pay their full rent, but they've had time to save. They've had time to learn how to budget. You know, if they didn't have that full-time employment, they'll have it before then. But if not for this program, we wouldn't be able to effectively make these huge changes in people's lives. And when I talk about partnerships, More Than Words is an amazing partner, and all of this is partnership driven. So, they do court advocacy. It's a bookstore that has a brick and mortar shop. They've got another warehouse in Waltham, but then they've also got an online shop. So when you're working there, you're learning sales, you're learning administrative duties, and it's set up as a program where you can't get fired. If you mess up, there's a suspension. You have to have a kind of suspension meeting with your case manager. You learn from your mistakes, you grow, and you keep going. And they've had amazing success with their young people in the last 20 years. I mean, and it's an honor to have them as one of my official partners, one of my main partners. But no, I mean, this program is something as a pilot. It's piloted out of Dorchester Courthouse, but I've already met with all the ADAs, and I think our 9 district courthouses, and said, listen, if you have a young person that you think would be appropriate for my program, let me know. As long as it's in Suffolk County, I'll look at it. And I'll just give you an example of a case that came across a referral recently. So you've got, and this will show you how I feel like this program really meets justice out. 2 young men driving in a car. One of the young men is, maybe 23, 24. Other young man's about 21. They get pulled over. The state trooper that pulled him over said he noticed a movement in the car. He orders them to exit the vehicle. They do a search, and they find a firearm inside a crossbody bag. Anyone that's 40 and over, we call them fanny packs. But they find a firearm in the crossbody bag. No one claims it. So they both get arrested. When they get to the state police barracks and they're being separated in separate cells, the older young man profusely apologizing to the younger young man. And, they're like, well, now we probably know whose gun it is. But subsequently, they both got charged. They both got arraigned in court. And under mass law, gun possession and, not brandishing, not pulling out, not shooting, but gun possession, which they were charged with, is a mandatory minimum of 18 months. Now you got this young man, and I don't think I added the older gentleman, had a fairly long criminal history with firearm charges on his record. The other young man had no record. Matter of fact, he was in school. Now you take him away and put him away, and you put him in jail, incarcerate him for 18 months, the trajectory of his life has completely changed, whereas he may have been on the cusp of street involvement. Now he's possibly becoming a real criminal, or he's joining into alliances to survive in jail, or he's gang involved. So now you had someone who was in post-secondary education, that was working towards, becoming a productive member of society. You incarcerate him for 18 months, and now he comes out, and, who knows what's happening. And with incarceration, especially for this population with developing brains, it either slows or stops brain development severely. So now you've got someone coming out where he hadn't been a danger to the community before, but now he's coming out and he possibly is a danger to the community, and the community is less safe. And that's what I mean by having a district attorney that's more forward thinking and understands brain development, especially in this emerging adult population, really drives innovation like this and programs like this. But anyway, like I said, it's an honor to be able to speak in front of you guys and let more people know about this program. Please, meet me afterwards, and I'd love to give people cards and answer any questions and talk more about this. So thank you.
Okay, all right. So we've got 7-8 minutes for questions. I just want to note that our NJAM trainees will be training in this environment. It's a training in applied neurolaw. It's not just writing philosophical treatises. It's really being in the community. All right, so there are 2 microphones for questions. While you're getting there, I've got one which could go, I guess, to any of the panel. Maybe I just directed at Judge Ullman, which is, as a judge, when you're confronted with this and you've raised the question that you were there to evaluate some of the advances in neuroscience, but obviously you're trained in law, not in science. How do you as a judge, how do legal professionals come to a field that's as complex as neuroscience and try to make some sense of it?
Well, as judges, we rule on all sorts of things where we're not experts. I mean, hopefully we're experts in judging. Yeah. Right, at least on our best days. So it really is it took me a lot of time. Science was not my strongest subject in high school. There's no substitute for just taking the time, and I would read over the testimony multiple times. I would read articles. I would look at citations that were in these articles. And over time, you just see consistency. You see the same, just the same results. And ultimately it gets boiled down to a certain limited number of findings about how 18 through 20-year-olds differ in terms of their risk-taking, lack of impulse control, susceptibility to peer pressure, and brain plasticity, which correlates to ability to change. So, but this took a ton of time. I will say this, but of all the cases that I worked on as a judge, this by far, took the most time. But ultimately, I don't have to become an expert. I have to be comfortable in my own head with the factual findings I'm making, that they do hold up.
Thank you. Theresa.
Can I?
Oh, yeah, quickly.
I just want to weigh in a little bit on that from another role, which is somebody may be providing testimony in court. So 2 things I try and be mindful of. The first is the level of detail that would inform a judge, but not put a legal finder of fact, whether it be a judge or a jury, to sleep. They're not interested in neural cell metabolism. That's not sort of where they're at. So I don't mean this to be dismissive in any way. I think of as if I were to watch an 8-part PBS series, what would I then know about fill in the blank, right? It would be accurate. I would have a grip of the gist, if you will. I love Nova. I will never be an astrophysicist. But now I can at least give a working man's definition of what a black hole might be, right? And that's all I need to know for the limited purposes. The other thing is, I also know that judges have legal tests in the back of their minds. So I'm also trained as a lawyer. I love issues of evidence. And so I'm being asked the questions, but I work out with the attorney who's going to be doing the direct examination. Can we at least talk about some of the things the judge is going to have to know about? Like, is this an outlier study or is this in the center of the science? Has this been published in peer reviews? Is it testable, right? All the kinds of things that we think about from almost a philosophy of science kind of process of thinking about this as science that is solid. How do we convey to a judge, how do we know that this is solid? And that's partly because they do have legal tests that emerged because there were some very, very large tort cases that got to the Supreme Court where it turned out ultimately that the science was flawed, but the legal decisions had already been made. So they revisited the tests for scientific reliability in court. So if you're going to be a witness on some of this stuff, at least talk with the attorney who's presenting you to make sure that you get to talk about the reliability of the science and not just the substance of the science.
Yeah, so thanks for all the work you've been doing. You know, I think often law is so incremental that just being sort of the first movers in this space by itself is a huge success. But I guess my question is sort of how do we take it from the state of Massachusetts to other states or, you know, the country, you know, more widely? Would just love to hear any thoughts about how you can sort of share the work you've been doing here to a larger community outside of sort of Suffolk County and Massachusetts. Thanks.
Well, one of the things you can do is get into the network of people who are working on this issue, either from an advocacy point of view or from the sort of science side. Organizations like the Sentencing Project, for example, they will know where there are cases that may have landmark precedential value. So I learned about a very similar case in Washington State and another one in Michigan through that network, not because I'm sort of following the weeds of law as it progresses in Washington State. The other is to think about folks who are trying to do things outside of Massachusetts, like raise the age or second look legislation, and be prepared to go present the science to legislatures. So I've been in Rhode Island, Vermont, Michigan, all over, giving a version of what you just heard in the 5 minutes of fame I will have in the middle of a legislative testimony.
Let's do this. We are basically at the end of time. Let's take both questions from the trainees. Tell us who you are, what your question is. I'll direct them. We'll have a very, very short reply and we'll get to our keynote. But please introduce yourselves and ask your question.
Francis, real quick.
Oh yeah, Ms.
Can
Waddy,
I
very
just
quickly.
say something real quick about getting the word out and national? I'd love, and I am working as hard as I can and expect that the emerging adult program becomes a national model. I think our collaboration with Harvard Center for Law and Brain Behavior really gives the program credence, gives it legitimacy. And as a pilot program, I'm uber focused and very intentional on the initial participants during this first iteration. If we can have as many successes as possible and show that this works and this creates safer communities and creates more productive young people, rather than being so punitive and just locking people up. I always say Boston's been the first for so many innovations in this country, in the world. And so why not this? But yeah, hopefully this can become a national model and really change the criminal legal system as we know it, especially for this emerging adult population.
All right, introduce yourselves and your questions.
Hi, thank you all for the discussion. My name is Javier, for those of you that don't know me. I have a question for the panel broadly. I'm very curious as to your thoughts, given your perspectives as to sort of the role of technologies in changing the young adult brain. I think we're at a time where potent social media apps are available and legislated. Also, there's a lot of portable neuroimaging technologies emerging that can give us insight into brains of people that have been underrepresented in science. How stable do you think our understanding of the physiology of the young adult brain is today, and where do you think it might change in the future, if ever?
Let's take our next question also. That's a big question and a good one.
All right, so thank you. My name is Sophia Riskin, and I have a bachelor's in neuroscience from Smith College. And my question is, so while I was in college, I conducted a couple of years of research at MIT in brain and cognitive sciences, in developmental psychology and developmental cognitive neuroscience, and with some of the pioneering neuroscientists in the world. And what's really interesting to me is that several of my principal investigators and my mentors, who are graduate students and postdocs, who are doing research that I feel is very relevant to what we've been discussing today, both in terms of neurotechnologies and in terms of juvenile and emerging adult justice, feel that there is a very big gap between the research that they're conducting and what's happening in the courtroom in terms of law and public policy. And I disagree. I think that we could absolutely use some of the research that they're doing in the applications we're talking about today. So my question is, how can we help to bridge the gap between the researchers who are in these institutions doing research on children's developing brains and the kind of work that we are discussing today?
It's another fantastic question, but what I'm going to ask us to do is we're going to thank our panel. We're going to have our panel go because we're now at least 15 minutes over. We have a keynote speaker who is ready to go. And those are big questions that deserve some lengthy conversation. So we'll thank our panel, and then you guys can huddle. Can you please join me in thanking this amazing panel and all the work that they're doing? We'll kind of shift off and we'll connect with you over there to talk about those, and we'll hear from our keynote, Theresa Skelly. So, thanks everybody. That was great. Sorry. Yeah, no,
So we're definitely gonna get.
Okay, the goodness just keeps going. This is so exciting, and I'm really, really honored and excited to have a really dear friend here, but also, just a really impactful member of our Boston community. And I'd like to shout out just a couple other people that she actually connected me with, but that are with us here today helping out. So Rabat Jocelyn and his team from Massive Media are also local folks that are helping us with our video and technology skills of actually getting the word out, because as you can see, there's a lot of amazing stuff happening. And as you hear, not a lot of you know about it. And so they're going to help us do that a lot. And then the team from Everybody Gotta Eat that will be supplying our lunch today. Their food is absolutely delicious. So that's going to be a really big treat as well. And I'll give you some details after we hear from Theresa Skelly. So her formal introduction, I think the reason why she's here and we're so excited to have her here is that she's taken what is science and what is community and culture and made it a real thing. And I've had the pleasure of watching her do that to the point where, this past a week ago, she opened a restaurant and business in the Children's Museum of Boston, and just a real impact from what she cares about deeply, what she knows about the science, and then what's actually happening on a day-to-day basis, which I think transitions us beautifully to what we're going to do this afternoon, which is talk about how do we actually bring this to reality, talk to people, make these things real. So Theresa is the founder and CEO of Little Cocoa Bean Company, a wellness-focused food brand committed to transforming early childhood nutrition. A dynamic advocate for health equity, Theresa brings a lived experience and community-centered lens to the challenge of reshaping how society feeds its youngest members. We have a couple of those little members too. Sometimes they like to join us. Though her work designing thoughtful food experiences, she addresses critical intersections of public health, brain development, and systemic inequality. With a focus on the first years of life as a pivotal window for cognitive and physical development, her mission aligns deeply with the goals of neurotech and justice. Her insights reveal how early dietary exposures affect long-term health outcomes and social opportunity. As a mom, entrepreneur, and community builder, she leads a growing movement to reclaim food systems for families historically underserved by mainstream markets and policies. Please join me in welcoming Theresa Skelly. Oh, she had no voice because our kids.
That's right. We can thank the kids for lots of things, including their germs. So apologies in advance for my voice, but good afternoon, everyone. Thank you for that warm welcome. And thank you to the organizers of the Neurotech Justice Summit for creating a space to explore how we can innovate, not just with technology, but with purpose and inclusion, and with justice at the core. I am honored to be here today. My name is Theresa Skelly. I am the founder and CEO of the Little Cocoa Bean Company. We are a food and wellness brand that is reimagining how families, especially families with young children, experience food. But more than that, we're an example of what it looks like to build something rooted in data and community, in science and in lived experience. Our mission is simple: to transform mealtimes into moments of nourishment, connection, and joy. But our work is anything but simple, because feeding children in this country and feeding them well is harder than it should be. I came to this work, as many entrepreneurs do, by trying to solve a problem that was deeply personal. When I became a mother, I was overwhelmed by how hard it was to access food that was healthy, joyful, and culturally inclusive. As a first-generation American, I grew up in a household that regularly consumed fresh whole foods, foods that told the story of my Panamanian roots. But when I tried to offer that same nourishment to my child, I was confronted with a food system that made it easier to buy processed snacks than fresh meals, that marketed sugar and sodium to children, and that didn't reflect the diversity of the families that it claimed to serve. And the truth is, I knew then that this wasn't just an annoying personal problem. This was a public health issue, because we know the science. We know that the first few years of life are foundational for brain development, immune strength, and long-term well-being. Nutrition during the early years is absolutely critical. Harvard's Center on the Developing Child and numerous longitudinal studies confirm that proper nutrition in early childhood supports cognitive function, emotional regulation, and even future academic performance. And because we know the science, we know that the first few years of life are foundational for brain development and well-being. Emotional regulation and future academic performance. But these benefits are not equally accessible. Across the US, children of color, children from income-constrained families, and children living in food deserts are disproportionately affected by poor nutrition. These are communities where access to affordable, nutrient-rich foods is limited or non-existent, and where preventable diet-related diseases show up earlier and more frequently. In many of our households, this is not about a lack of knowledge. It is about a lack of access. It's affordability, it's time, it's the constant battle with a $10 billion marketing industry that teaches children to crave the worst foods on the shelf before they have even started school. And I knew that I could not wait for someone else to fix this problem. And it was in that moment that the Little Cocoa Bean Company was born. Together with a small team of like-minded individuals, we decided that we didn't want to just talk about this problem. We wanted to build a solution. We started small with homemade meals in my kitchen, and we listened. We listened to caregivers. We listened to kids. We listened to public health data, and we listened to our own experiences as parents and community members. That listening shaped the Todd Cafe, our flagship eatery designed specifically for families with young children. It's a fast casual cafe where healthy, colorful meals paired with a Montessori-inspired play space is a beautiful and welcoming, joyful place where parents can exhale and kids can eat and explore at their own pace. We've partnered with pediatric nutritionists to ensure that our recipes support the unique needs of growing bodies and brains. We've designed food that's fun. We have waffles dyed pink with beetroot, a broccoli grilled cheese, and even veggie-packed desserts, because we believe that food should be good for you, but it should also be delightful. Our cafe is designed for both kids and caregivers. It's the kind of place where kids feel welcome and parents feel seen, and we have witnessed extraordinary results. Children eat better at our cafe than they do at home. Peer influence, positive association, and a joyful environment make healthy eating feel less like a chore and more like a treat. And we are not stopping at one cafe. We are building a movement. This year, we opened our newest Todd Cafe inside of Boston Children's Museum. As the museum's exclusive eatery and on-site gift shop, we have access to nearly 500,000 visitors, 500,000 moments to introduce families to food that feeds the soul and the body. It's a chance to make healthy food a part of everyday life for families from every background, and a powerful platform to shift the norms around childhood nutrition. We are scaling thoughtfully. Alongside our move into the museum, we're launching packaged products, an online portal for families, and we're partnering with schools and hospitals. We're working to ensure that our food is accessible wherever children are eating. Access and dignity go hand in hand. And that is also why, with the support of our funders, we have raised money to provide 4,000 free meals at our cafe to income-constrained families, no strings attached. And we're doing it without asking anyone to take a walk of shame or to prove their eligibility. We are printing cafe gift cards, placing them discreetly near the register, where any family can pick one up and enjoy a meal. No explanation required, because dignity is part of wellness too. At every step, we have centered community. Our growth has been fueled by word of mouth, by parents telling other parents, by listening deeply to what caregivers and kids actually need. We don't believe in designing for the community. We believe in designing with the community. That's how you build something that lasts. That is how you build something that matters. And that is what brought me here today. We didn't get here by chasing trends or by throwing money at a problem. We built this by starting close to the ground, staying close to the people that we serve, and believing that you can hold science and culture, rigor and joy, business and community in the same hands. This summit is about justice, and justice in innovation means putting people at the center. It means taking what we know from science, from research, from lived experience, and creating solutions that are inclusive by design. So whether you are building in neurotech or in any other space, I want to encourage you to hold space for both the data and community, for intention and experimentation, because that's where the magic happens and that's where justice begins. Thank you all for allowing me to share my story today and for the work that each of you are doing to make a better and more equitable future. Thank you.
Thank you so much, Tracy. I was just asking her for the details. She has a campaign, which you can donate to. I'll just throw it out there because she's too humble to do so, where they're actually feeding families. One of the partnerships in the city of Boston is that our kids on Sundays go to the museums for free. But when they get there, what do they eat? So at her cafe, they actually are up to 200,000 free meals for kids when they come to the museum. So it'll be exploration plus healthy food. So thank you all for being here today on the behalf of the three of us, the three triplets, the three amigos, however, you obviously can see the resemblance and passion for neurotechnology. We are thrilled. This is just, a dream coming to life for us. So thank you for being here. Thanks again to everyone that participated and all the work that we've heard about. Thank you so much.
Thank you.